Welcome to today's webinar. The topic today is seismic design according to Eurokódu 8 in RFEM 6 and RSTAB 9. My name is Andreas Hörold. I'm responsible for marketing and public relations in the Dlubal Software company. For instance, the Dlubal website, German and English webinars, then the press releases, etc. I will be the moderator today.
Yeah, hello, my name is Stefan Frenzel. I will give you the presentation about RFEM 6 and of course the Dynam add-on today. I work here at Dlubal for the product engineering of the Dynam modules and also in the customer support.
Hello, so my name is Stefan Hoffmann and I'm responsible for customer supports, and I'm also within the development of the dynamic add-ons, and I will be taking care of your chat questions today. Whenever we do not manage to answer them within the webinar, you will receive a mail later on.
Okay, thank you for the introduction. We can switch off our webcams that the attendees can see the full screen. Okay. You can ask questions via the control panel on the right side of your screen. You can show or hide it with the arrow here and ask the question here. The other way is to watch the entire webinar and then email your question to info@dlubal.com. To the agenda today, first point is modal analysis using a practical example. That's the example here on the right side of the screen. Then point 2, seismic design according to the response spectrum analysis. Then use of results for the structural component design. And the last point is printout report documentation. Then I hand over the screen to Stefan Frenzel. Stefan, it's your turn.
Okay, so yeah. Hello again. So, in the first part, I want to show you today the RFEM 6 with a new Dynam add-on, where we want to do here a model analysis for the structure, which you can see here on the screen. That should be here. Our structure today is made out of concrete, so we have here some concrete slabs, also concrete walls, and also concrete surfaces here in this case, or floors. And for this structure, we want to do here at first today a model analysis. You see, of course, here in the control panel, of course, the material and also the surface thicknesses. Yeah, I think that is already known. But how we can do here a model analysis in this case. So in RFEM 6, we have here a new type for model analysis. So it's not an add-on module like an RFEM 5. So here is it possible to do the model analysis global in the system. So that means we will have also the results here in the table on the bottom, and also the input data here in the navigator on the right side. On the left side, sorry. So of course, here if we want to do a model analysis, we have to go in the base data of the program or of the file what we created before, and there is it possible to switch on or off add-ons. So that means we have here also parts for analysis add-ons, and here we have the parts for the dynamic add-ons. In our case, we want to do it first here a model analysis. That means we just have to switch on this model analysis button, and that's all for us. Yeah. What's important here, we have also for the add-ons, we have here also design codes which are in behind. So that means when we click here on standards 2, then is it possible, of course, to choose a design code according here, for example, according to Eurokódu 8 for the dynamic. Yeah, you see we have here now a red national annex. That means this national annex is not guilty anymore. So we take here, of course, this national annex. Of course, that's the last one. Yeah, and that's normally all in the first step. So if we click now here on OK, then you see, of course, here on the left side in the navigator, that is now possible, or that we have here some parts more. So that means we have here, of course, the model analyzer settings, which are added by clicking on the model analyzers in the base data. And therefore, is it now possible to do a model analysis. So, but how we can do a model analysis? A model analysis is here not anymore an add-on module, so we can define the model analysis directly in a load case. That means we have here in the load cases the categories, and for this category, static analysis is clear. We can calculate internal forces, but here is it also possible now to do a model analysis. If we want to do a model analysis, then is it of course possible to choose the masses which have to be imported in the program. Yeah. Therefore, you see here load case number 1, the self-weight. So we want to import the masses from load case 1, where we are in, yeah, to this model analysis. That means the self-weight is activated, and of course we have here some model analyzer settings. That means model analyzer setting 1. We want to calculate 4 eigenvalues with a Lanka solver. So here's it of course possible to change the settings, or you can also add some settings, or you can delete the settings if you want. Yeah. These settings are normally just important for the model analyzers. That means at first you have to choose, of course, how many eigenvalues do you want to calculate for the structure. In our case, we have 4 eigenmodes. And of course, here is it possible to calculate automatic to reach the maximum natural frequency. That means you give in here a maximum frequency, and the program will calculate so many eigenvalues until 1600 Hertz in this case. Yeah. For our example, we want to do a user-defined analysis. That means we want to calculate at first 4 eigenvalues. Yeah. And that's normally all. We have also some settings here. That means the settings for the model analysis are also important, because here you can choose which component of loads should be used for the model analysis. Yeah, the standard one is of course the set components of the loads. Is it also possible to use set components of loads in direction of gravity, or full loads as masses? That means all loads in each direction will be calculated as mass and will be used for the model analysis. A next step is also to neglect masses. Yeah, for this one, here is it possible to do no neglection. That means that you calculate all, or that you do the calculation with all masses. That means that you do the calculation with all masses. Then is it possible, of course, to neglect masses in all fixed nodes, or in all fixed nodal and line supports. That means the program will deactivate then the masses for this. Yeah. So then we have here also a user-defined option. This user-defined option is really easy. You can directly choose, surfaces, lines, or members, or also nodes where you don't want to have the masses included in the calculation. That's I want to show you later a little bit. At first I want to click here on OK, and then we click also on OK. Okay, we have to delete the results. That's clear for us. Yeah. So now you see here on the top that we have here a small red button and a blue one. The red one means just for us that it's not a static analysis. So that means here for us it's a modal analysis. Yeah. We do here now the calculation for this. And then you will see that the program will now calculate the eigenvalues of the structure with a Lanka solver. Here is just one core of the computer used. That's caused by the eigenvalue analysis. Is it not possible to use more cores than one? And then you see, of course, the results. That was normally really easy. Yeah, so we have now here the natural frequencies. where you can choose. So for example, the second frequency or the third one, yeah, and that's all now in the navigator, so in the navigator of the results. Another thing is that it's here possible to have a look in the table on the bottom, and here on the bottom table you can have a look, of course, of the a look on the national frequencies, where you can see here the eigenvalues, the natural frequency, the national period. Then you see, of course, the effective modal mass factors. These effective modal mass factors are also important, yeah, because normally we need 90% of the effective modal mass in each direction for the earthquake calculation, yeah. And these ones you can see directly on the top or on the bottom. We have also the rotational effective modal mass factors, but that's normally just for development. Yeah, that's not so important for the normal user, because the normal user who wants to calculate earthquake loads use normally just the translational effective modal masses, which are in X and Y direction, and maybe sometimes in Z direction. The participation factors are also given out here. You can see it on the bottom. And then you see, of course, the masses in mesh points. Maybe you know this from RFEM 5 here. Was it also possible to have a look on the masses in the FE mesh points? That's normally not so easy to take a good look in this table, because you have to scroll down and maybe you don't find your node what you want to use, yeah? And therefore we have now a graphical output for that. And that means you just can go here in the navigator for the results, and if you click here on masses, then the program will show you all masses in each FE mesh point. That looks not so nice now, but I can maybe a little bit zoom in. And then you see, of course, mass balls, we call it mass balls, in each FE node. And here, of course, you can have a look on them, and maybe you can also say, okay, for example, you want to deactivate the masses for this surface or for this top surface, then you can control it afterwards, yeah? So that's what we want to do now. We go on edit, and here in our model analyzer settings, we can here neglect the masses. I want to use now user defined, and maybe I just want to show you the surface. Wait a second, surface, and then I just have to click my object, what I want to have, and that's all. So please neglect masses in all directions and around all directions. And if I do this and do the calculation again, then I will get, of course, the result. And when I have a look on the masses now, all masses will be neglected on the surface. I think that's, of course, an advantage in RFEM 6 that was not possible so directly in RFEM 5, yeah, because here you see now also directly the values on each point, on each FE mesh point. And it makes it really easy to control the whole result, yeah. Another option, what you can do here, if you do such a model analysis, it was in RFEM 5 also like this, it was possible to add additional masses, yeah, but there was it just possible to add additional masses in the add-on module. Here we changed it a little bit up, and here's it now possible to add masses with the normal nodal loads, line loads or surface loads, yeah. So because if you click now here in the nodal load, for example, then is it possible for the load type to choose, of course, a mass. And if you write in here a mass, maybe 20 tons, and you put it in here, then you will see in load case number 1, of course, here a mass ball with 20 tons. And this mass ball is also considered now in the model analysis of the whole structure. Yeah. That's just what I want to show you here, what's also important, because it's also possible to do it for surface loads and also for member loads, to add additional masses in the program and to have a directly view of them. Yeah. That was not possible in the old programs, and that's also an advantage here. So then I want to delete this load, because now I think we want to do here a modal analysis, a real modal analysis for the whole structure, yeah, and therefore I will at first change my model analysis settings, because here we have also the neglection of masses on, so we don't want to have this, and maybe here we want to calculate 12 eigenvalues, but with a diagonal matrix, what is nearly, or what is completely enough for a calculation afterwards for earthquake calculations, because we just want to consider the x and y direction, and therefore I deactivate the other directions, or the other direction z, and also about the axis x, y, z, because it makes no sense for us, and the calculation is more faster when I don't have to consider all directions, and of course it's easier for me to reach the 90% of the effective model mass factor afterwards. Yeah, so I don't need so many eigenvalues for that. Means the performance is better than afterwards. Okay, now we are here in our structure, and how was it in the old one? Or it was normally always like this, that we did here a static analysis, or did we, wait a second, I just have to change it back. That we now here need, of course, a model analysis. So if we want to do such a model analysis, then I have to choose at first a design code. For example, here in our structure, should it be the Eurokódu 8? Yeah, you can also choose AISC or whatever. That it's not so important for the program, but the important thing is here we can now create here a design situation. For this design situation, is it possible to create a seismic mass combination? That means that the program will calculate a mass situation for our model analysis according to a design code. And the program will do it automatically. So that means for us, if I go here now on action combinations and load combinations, the program creates here a load combination. So now I have here, of course, my masses, which I need for the design, or which I need for the model analysis according to the standard. And to take now this mass combination or load combination in this case, yeah, I can go here in the base in the load cases again, and can create, of course, a new load case. This new load case should be, of course, a model analysis. I have here my model analyzer settings, what I changed before. That means here we want to calculate 12 eigenvalues with a Landgraf solver. Yeah, that's all at this point. The important thing now is that we can use here the automatic created load combination for my seismic mass combination. Yeah, and that's the important thing, because that was not possible in that was not possible in the old one. Here is it now possible to consider this mass combination or load combination for the calculation of the model or of the eigenvalues. With this option, we go here now on OK, and then we do a calculation of the whole structure. You will see now the program will calculate all load cases and, of course, the seismic mass combination, and afterwards, yeah, the load case number 7, my model analysis. In this case, you saw also that the program calculated all load cases nearly directly at the same time. That means we have here now a multi-core calculation. The program can use, of course, all cores of your CPU, which makes it, of course, really fast in this case. Yeah. So now we want to deactivate, of course, the masses, because I don't want to see them. Here maybe I want to have a look on the mode shapes. Yeah. But what is important for me now here, it's really easy. The important thing, or of course, the effective model mass factors. So therefore, I just have to click here on the model analysis, yeah, the national frequencies or the effective model mass factors, what I want to see. And now I can see, of course, I have 97% in the X direction, and of course 94%, nearly 94% in the Y direction. What is now really good for me, because with these values I can do, of course, a response spectral analysis. But how we can perform as a response spectrum analysis, that is now the important thing for us. Yeah. To do a model response spectrum analysis, we have to go back, of course, in the navigator. And in the navigator we have to click again on the base data, because here in the base data we can switch on and off our add-on modules, with what is also important for us. In this case we go on the add-ons, and here's it now possible to choose the response spectrum analysis. The response spectrum analysis here will calculate, of course, the internal forces of the whole structure, and with these internal forces we can work then for the design, of course, for the concrete members or for the concrete surfaces, because afterwards we can create here a result combination with the maximum loads in this case, or the maximum internal forces. So now you see here the response spectrum analysis, what we added. Then we have to go, of course, here in the standards 2 button. Here you see, okay, we do the calculation according to the national annex of the Eurocode, and of course for this national annex we can now also just create here our response spectra. If you want to have a response spectra according to another code, then you have to change, of course, here in the standards 2 window, the national annex or the design code. Yeah, you can also choose here, of course, the ASCE 7, or you can also use the old DIN. Of course, you can use here in the Eurocode also the other national annexes which are here available now for the program. You see that we have a little change in the national annexes, because now you see, of course, the year of the national annex. That is also important, because so you know what national annex you want to use. We have also some national annexes which are red, because they are not, so they are normally not usable in Germany, for example. Yeah, that's the old one. But here we have the new reputation, and therefore we can take this one. Okay. Oh, sorry, I closed it with cancel. That was not so good. I have to activate it again. Okay. So if we do such a calculation, or if we do here such a response spectrum analysis, then you see that we have here spectral analysis settings now as a new part. Yeah? And of course we have here on the bottom the dynamic loads. The dynamic loads are also important, because in the dynamic loads is it possible to create response spectra and also to use accelegrams from real earthquakes. Yeah, so that are recordings from real earthquakes, and these accelegrams you can use and can do a calculation of the response spectra of out of this accelegrams. Sorry. So, but how we can perform now here a response spectra analysis? Okay, that's really easy. We go here on edit again in the load case and create, of course, a new load case. In this new load case, we have now a new analysis type. Yeah, so you see that we nearly do all in the load case, and here's it now possible to do a response spectrum analysis. This response spectrum analysis has also some spectral analysis settings, and you have to import, of course, the modal analysis from a load case. But that's really easy, because here we take, of course, the load case number 7, yeah, and the spectral analysis settings I want to show you here. So for the spectral analysis settings, you have here the option to do, of course, a modal combination, yeah, with a SRSS or CQC rule. Which one you have to use, you can also find in the design code, Yeah, for example, in the Eurocode 8, there are some formulas for this when you have to choose the SRSS or CQC rule. In our case, we want to use the SRSS rule. If you choose the CQC rule, you have to give in a damping, yeah, because this damping is used then in the CQC rule for the calculation of the internal forces. With the SRSS rule, the damping constant is nearly 1, so that means we don't have to do a damping constant in this case. For this one, we have here use equivalent linear combination. That means that the results, so the internal forces, normal force, shear force, and the moment will match together. Yeah, that's normally state of the art, we can say. So this one you have to use, of course, and then you have also the option signed results using dominant mode. I think maybe you know it from RFEM 5. There was it also possible to do a calculation and then to put over the whole calculation the signs from the dominant mode, yeah, so that you get just one result and not two results per each node. This one we don't want to use now, but here's it possible also to save results of all selected modes. That's also a good thing, because therefore is it possible to have a look afterwards to see all results, what the program will calculate internally. Otherwise, the program, or you will get just the XY direction in our case, and not the XY direction for each eigenmode. The combination of the directional components is also important. Here in our case, we want to use, of course, the scaled sum. That means we have here a 130% rule. You see this, the 30% value is changeable. So, for example, you have nuclear power plants or something like this. Maybe this rule needs a change. Then it's also possible to give in here a user-defined value. Yeah. In our case, we want to take this one, and this we can also do with a click on OK. Then we see, of course, some small infos about it. SRSS rule, scale sum, 30, yeah, that means scale sum 130% and 30 100%. It's also possible, of course, here in the options to consider the accidental torsion. So that means we have to give in the eccentricity, which we can calculate, of course, by the building length. Yeah, so we can activate this, and the program will also take directly the building length in X and Y direction. We can also take user-defined length if we want. Yeah, these 5% are out of the Eurocode. Maybe other codes have another value. That's why you have the option here to change this one. Yeah. Okay, in our case, we don't want to consider the accidental torsion. We want to switch now to the response spectra, because for we have to edit, or we have to create at first now a response spectra, what we want to use here for the calculations. In our case, we want to have a response spectra in X and Y direction, because the direction we neglected before for the modal mass analysis, so we don't need this anymore. So we do just a calculation for the X and Y direction. And here for the response spectra, is it now possible, of course, to edit the response spectra. As I told you before, you can see here the definition type according to standard Eurocode 8 from 2021, so from this year. And here's it also possible to give in a user-defined, or to take one from the or to generate from an acceleration. Therefore, of course, we have here a database I can show you from library, yeah, and there you see, of course, many accelegrams. So we have here 2,490 accelegrams from over the world, which you can use now to do a calculation, or which you can use to create a response spectra out of that. Yeah, for example, Georgia. Yeah, this one you can use also. So, but here we want to use it from. We don't want to use an acceleration. We want to use this from the Eurocode. If you do it from the, or if you want to use the spectra from the Eurocode, we have to go, wait a second, on dlubal.com. And here's a possible, wait a second, it's in, sorry, that is in German. That was not so good. Here you see on support and learning, or no, on the solutions, sorry, the snow load and wind speed seismic load maps. And for these ones, of course, you can choose here seismic and can take the values, for example, here, maybe from Germany, Eurocode 8, and of course, no, I can't find Germany. Is it my problem? That's good. Okay, we see here the old German code, but here normally we should have also, now we have Germany. Okay, sorry. And here you see, of course, the SAPR, so that means it's the spectral analyze, or the spectral value for that, yeah. And of course the AGR, so which is the acceleration for this or for Berlin, for example, yeah. Otherwise, is it also possible to enter a location and to get here the real values what you want to use in this case. Here in our case, we take the input values which are given directly, yeah. It's also possible, of course, to take here maybe another ground type, or maybe we take here another value. SAPR is 1.5. Yeah, okay, that's okay. The important thing here is that you see, of course, the response spectra, and if you click here on OK, you have here a selection of the modes. The selection of the modes were also in the old Dynam Pro module in RFEM 5. You find it here now also in the load case, because it's now a property of this load case, and here's it, of course, possible to take here the 5% value, yeah. That means for you, okay, we have now here 91% in X direction, which is of course okay, but here in the Y direction we have just 87%. So normally we need so many eigenvalues that we reach the 90%, and we can, of course, take all eigenvalues which have a higher factor than 5%. In our case, we want to take 4%. Otherwise, we don't reach this 90% in the X and Y direction, and therefore here we take a value of 90% of 0.04. Sorry. Yeah, that's normally all for this. Now we can go back on the main tab, and now it's possible, of course, to calculate all. You see that the program will calculate now many load cases 8, so that are sub-results, yeah, and that's mean the program will calculate them internally and will give you then, of course, the results for this one. If you deactivate the sub-results in the spectral analysis, then the program will just calculate the X and Y direction, and that's all normally, yeah. Now you see, of course, here the results, yeah. At the end, the important thing is the scale sums envelope. That means the 130% rule or the 3100% rule. That's the scale sum envelope. But here we give you also the X direction, so all results in X direction, and of course all results in Y direction. And then we give you, of course, the results for each mode in each direction, yeah. What you can see here now, we just get internal forces. So the program will do a calculation of the internal forces directly. That saves a lot of performance, because in the old program was it like that we calculated some earthquake loads, and we get in the old program in each FE mesh point an earthquake load, and that was yeah, that was really time consuming in this case, and this we switched a little bit, and we calculated here directly the internal forces for the whole structure, what it makes more easier and more efficient in this case. You see, of course, here for the spectral analyzer an overview, and of course the load case number 8. Here's it also possible, of course, to have a look on the results by the member. Yeah, that's always possible. Normally, is it enough to have a look here on the results? Yeah, because these results of course are important for us. Yeah, but at the end we have to do normally a calculation of the of a new load combination or of a new result combination, where we also consider the self-weight of the structure. So that are just the earthquake loads in this case. And that's now, that was the problem in the old program. In the new program, is it no problem anymore? Because here the program will do a calculation of these special design situation, and will do it completely automatically. Yeah. So, but how we can do this special design situation? Therefore, we can go, of course, back in the edit module for the load cases, and here is it possible to create now a new design situation. For this design situation, we take here the ULS seismic, yeah, and for this ULS seismic, is it possible to create, of course, a result combination. So that means all design situation, or this, for this design situation type, oh wait, I have to cancel this because we have already a design situation, we need a new one. So in this case, we take here now, or we create now a seismic design situation, and the load combination, of course, according to the result combinations calculations. That means the program will do here this special design situation for us with a result combination. So we can click now on the result combination at the end, and then you see here, of course, the assignment, and you see that the program will get here, or will take here, the maximum design, or the maximum internal forces out of the earthquake design in this design situation. So therefore, I just want to show you that it's also possible to activate sub-results for the result combination. Because when I activate the sub-results, it's here for me possible to choose, of course, the scale sum of the envelope extra, or to do just to use some individual mode shapes. Yeah. For example, I just want to consider the X direction for my design situation, then is it also possible here, yeah? So I don't have to use the scaled sums at the end. It's also possible to take here another value for that. That is also new. The program will do here, of course, the calculation also completely automatically. That means for us, if we go here on OK, then is it of course possible to do here the whole calculation again. So that was all in this case, and I can have a look now in my result combination, where of course the self-weight of the structure is considered, and also the earthquake loads are considered. Yeah, and with this design situation, is it now possible to do a design according to a material standard? Yeah. For example, we can do it like this. We go in the base data and say, okay, we want to activate the concrete design add-on module. Then is it also possible now to go here in this design situation. This was this one. Wait a second. Wait a second, what is the problem? Oh, wait. Base data. Maybe yeah, okay. I clicked again on cancel, and that was my problem. So here's it now possible, of course, to go on edit, and then is it possible to do a concrete design also for my seismic design combination, which is normally a special design situation and which is normally not the ULS in this case. Yeah, normally you take here other design situations, but it's also possible to do this calculation now here for my concrete or for the whole concrete structure and to design according to my maximum earthquake loads. So that was this for the calculation, or to come to the results at the end, and also to do the combination of the results. Yeah. The last part should be here that I want to show you now, that is also possible to get now here the shear forces for each floor and also the deflection for each floor. That was also wished for RFEM 6. Therefore, we have here in the base data also an add-on module which is called building model. So for this building model, when you activate this, is it now possible to get or to define the floors by its own, and then of course to get the results for each floor in the calculation. Yeah. Therefore, we just have to define at first the building model. Yeah, that means for us, okay, we want to create a new one. My set top is -4, and here I want to create 6 floors without any diaphragm or something like this. You see, it's also possible to do a diaphragm calculation afterwards. Yeah, but here in our case, we created the whole structure with the real floors. Yeah, with real floors in this case, and therefore we don't need a rigid diaphragm for that. Yeah, that's why I delete this one and go on OK. So the program creates now here my stories for each, or my 6 stories in this case. Yeah, and here's it now also possible to get the results for this. Therefore, we go, for example, in this load case number 8, spectral analysis, and here we have now results by stories. What is really new here in the program. Here you see now, of course, the story forces from the earthquake calculation. You see, of course, the centroid coordinates, the interstory drifts, which are also important. Also afterwards, maybe you want to do something like in the direction of pushover or whatever, or you need to consider the story drifts for the calculation of second order theory. Then you will get here now directly the story drifts. You see, of course, the centers of the mass and rigidity for each floor, which is also important. And of course, you will get the forces in the shear wall. So the program will create result sections for each shear wall, and these values you can also use directly and can do a shear wall design for each story, or for each wall in each story. And that's also something new here in the program. What I want to show you. Yeah, you see, of course, here the result sections. There you see for each floor, each shear wall. Yeah, and these shear walls you can design afterwards. And of course, you will get the forces per length or per unit length for each shear floor, or for each shear wall in this case. Yeah. Okay. Then we want to come here now to the printout report. I just want to show you the printout report a little bit. Therefore, you can click here on New Printout Report. And of course, in the printout report, you will find the add-on modules like in the old RFEM. So you will get all stuff what you did here in the program directly in the printout report. So because yeah, That makes sense, of course. Yeah. So what we don't want to see: spectral analyzers, support forces. Yeah, maybe internal forces, bisections. We don't need. The interstory drifts are important for us, maybe, and the forces for the shear walls. Model analysis settings is also important. And then, of course, you see what's possible here. Yeah, the concrete design. We don't want to see graphics. We don't also want to see now in this first one. And then we can go on OK, and the program will calculate now the printout report. What's new here in the program? You will see, or it's now possible to work also in the structure while processing the printout report. Yeah, so you don't have to wait normally for that. Oh, did I wait a second? Printout reports. Oh, the printout report is created. Then we want to open this. And of course, you will see here the printout report. Here is it now possible, of course, to switch the printout report on each side. Then you can go here on RFEM again, and you can work also with RFEM. Yeah, normally it should work. Okay, it's been generating. Okay. You will see, of course, that you will get, or no, you will get, of course, here all stuff. Yeah, you will get here the response spectra parameters. Yeah, you will get here the building stories. Of course, you will get the load cases. Yeah, and in these load cases, you will see also that, for example, that you have a modal analysis, a response spectrum analysis. You see all options, what are used here for the calculation. Then you will get, of course, the static analysis results. And at the end, you will get also the model analysis results. So what is normally also nice, yeah, you want to print some pictures in normally. That's of course possible. Wait a second. Boop, boop, boop. Okay. Yeah, Andreas, okay. I think...
Yeah, Stefan, I think the forces in shear walls are printed in the printout report. That's a lot of content.
Was maybe not a good idea.
Okay, that would take some time, but it doesn't matter. You showed the printout report. It was a quick introduction in our new programs or our new add-ons. If you want to go through the webinar with the recording and with the provided model, then you can use the recording and the provided model. I will show you how you find them. Just a moment. I take over the screen now. When you go on our website, dlubal.com, you will find under News and Events here the webinars. Then the webinar of today. And in the next days, you will find here in the middle the recording and the presentation slides. And here is already the model. Okay, and then you can go through the webinar. If it was too quickly, we would like to show you in about 1 hour what is possible. But maybe it's it's a little bit too quick for you. Okay, then I thank you for your attention. Thank you to, I'm showing my webcam again. Thank you for answering the question, Stefan. And Stefan Frenze, thank you for the nice presentation. I wish you all a nice rest of the day. Then in some weeks. Merry Christmas and yeah, bye bye.